guys, this is Mr. Grice for Algebra 1, Chapter 10.2 Notes. Today we're talking about solving quadratic equations by using inverses. Our learning target today is to be able to solve quadratic equations by using the inverse or SADMAP, and to be able to identify the solutions or x-intercepts of a quadratic function when given a graph. So, methods of solving quadratic equations. Identify which methods can be used to solve the quadratic equation and why. Okay, now this is review from our notes from yesterday. So let's take a look at the first equation. It says 2x squared minus 18, that should be equal 0. Now the first thing we always want to do is check to see if we can take out a GCF. Okay, so we can actually take out a 2. And when we take out a 2, we're left with x squared minus 9 equals 0. So, how can we solve this? There's a couple different ways. All right. The first thing, okay, we can be factored. Okay. And the way we can factor it is by looking inside. That is the difference of two squares. Okay. We talked about the difference of two squares is when you can square both items and you have subtraction, or take the square root of both items. So difference of two squares. Okay, now another way that you can solve this is you can use inverses. And you can use inverses when there is no linear term. Okay, the review from that before is x squared is when it's quadratic. If it's just an x, that's when it's linear. And if there's no linear term, it means there's no x involved. Okay? And the last one, and remember, this can be on all of them, is you can use the quadratic formula. Okay? And that always works. Like, Mr. Grice, what's the quadratic formula? You're going to find that out soon. Okay? All right. Now, 3x squared minus 4 equals 0. Oh, my equal sign is missing. So what can we do there? Can we factor it at all? No, we can't factor it. But can we use inverses right there? I sure think we can. And you know why we can use inverses? Because there's no linear term. Okay? And then the one that always works is, I bet you guys wish you could do this on your paper. Okay? We can always use, what happened there? Edit. Undo. Edit. Copy. Edit. Paste. There we go. Okay. You can always use the quadratic formula. All right. Now, the next one, x squared plus x minus 42 equals 0. Can we factor that? Well, actually, yes, we can. Okay. Because a is 1, b is 1, c is negative 42. What numbers add up to get to 1 but multiply to get to negative 42? Okay, and that's where you would come down here, go 1 and 42, 2 and 21, 3 and, let's see, 14, 4, no, 5, no, 6, and 7. Well, then it's like, oh, it's 6 and 7. Okay, and that's got to be negative. So when we go through and break that down, the difference of two squares, you get x squared minus 6x plus 7x minus 42 equals 0. the difference of two squares, take out the x, you can take out a 7, and you get x minus 6, you get positive 7, x minus 6, and we get x plus 7, x minus 6 equals 0. So you can factor that, all right? So this can be factored because that's just what we did, and you can always, always, always use the quadratic formula. All right, number 4, you guys are all on your own. X squared minus 9x minus 18 equals 0. Go ahead and tell me which of those 3 can we use. All right, good luck. Okay, the only thing that works here is the quadratic formula. Something that you should always know or always do. You should always be like, well, A is 1, B is negative 9, C is negative 18. There's nothing that adds up to negative 9 and multiplies to negative 18. It just can't be done. I'm sorry. You can try as hard as you want to, but it just won't work. Now, solutions of quadratic equations. The graph of a quadratic equation is a U-shaped figure. We've talked about this. Remember that the name of it is called a parabola. The solutions of a quadratic equation are the x-intercepts. Once again, a review from yesterday. Okay, so now the answers, what we're looking for, are right there. What does x equal? Well, x equals negative 3, and x equals 1. And when we write those as intercepts, we write them as the points, the negative 3, 0, and 1, 0. Okay, for the next one, what's my solution? There's only one. Okay, it's right there. That's x equals, okay, you should be saying x equals 3 right there. All right, let's just point at these so we know that that's what we're talking about. Okay, and for this one, the last one, it doesn't cross the x-intercept or the x-axis, so there's no real solution. Okay, we talked about the little lazy bums. I don't want to write no real solution. Okay, you can write NRS, that's okay. All right, let's move down to here. Now, to solve a quadratic equation by using inverses, make sure it has, what does it have to have? Okay, no linear term. Okay, so what that means is if we have the x squared, well, normally a quadratic has that. We can't have that term, okay? Now, we've talked about inverses all the time, okay? Inverses, we're really talking about SADMAP. What are the inverses of addition? Well, the inverses of addition are subtraction. The inverse of division, you should know that, it's multiplication. And what is the inverse of an exponent of 2, i.e. square? Well, the inverse of that is square root, okay? It's the symbol that looks like that. Now, question for you. If you square root a positive number, the equation has how many solutions? Okay, so if you square root a number, how many answers does it have? And let's think of this backwards. If we say x squared equals 9, I want to know what is x. So what number times itself gives you 9? Now, in your calculators, you might be like, well, I'm just going to use my calculator to do this. Okay. We know what the square root button is. It's that button right there. Square root of 9. Oh, it's 3. Okay. Well, that's because 3 times 3 equals 9. However, that's not the only answer. There's another set of numbers that multiply themselves by, and that's -3. Okay? So when we're doing this, there are two answers. Let's flip back over. Okay? If it's positive, it has two real solutions. Now, if you square root a negative number, it has 0 real solutions. Now, does it have a imaginary number that we've kind of talked about? Yeah, okay, it does have an imaginary number, but we're not going to talk about that in this class. Okay? So, solve the following quadratic equations by factoring or by using inverse if possible. Round to the nearest hundredth or the second decimal when necessary, and always circle your final answer. So, what we're going to do is we always want the opposite side to equal 0. So, for our first equation, x squared equals 16. For it to equal 0, we're going to subtract 16 to the other side and get x squared minus 16 equals 0. Now, can we take out a GCF? No. But it's a binomial with subtraction, so we can do the difference of two squares. The square root of x squared is x. Remember, one's positive, one's negative, and the square root of 16 is 4. Anything with an x, you set it equal to 0. So x plus 4 equals 0, x minus 4 equals 0. And when we solve those, we get two answers. Okay, we get positive 4 and negative 4. Now, a cool symbol that you guys might not know is this right here. That means it can be positive or negative. And that kind of saves you just a little bit of time for all of you lazy folks out there. Okay, so number 6. We want to get one side equal to 0, so I'm going to add the 144 to the other side, and we get x squared plus 144 equals 0. So, can I take out a GCF? No, I can't. Can I do the difference of two squares? No, I can't. All right, well, let's solve it then by using inverse operations. Okay, so if I'm doing inverse operations, yep, we're going to move it back to the other side. And we get x squared equals negative 144. Now, the inverse of a square is a square root. And when you do that, you actually can't, okay, because it's a negative number. So x equals no real solution, okay? Remember, you cannot take a square of a negative number. All right, number 7. We always want to get one side all by itself. So we get 9x squared minus 36 equals 0. Good, it's equal to 0. Now, can I take out a GCF? Hopefully you're saying, Mr. Grice, of course we can. So we're taking out a 9, and we're left with x squared minus 4 equals 0. What can we do now? Well, inside is the difference of two squares, so we can factor this even further. Excuse me. So we get x plus 2, x minus 2 equals 0. Anything that has an x attached to it, remember, we set that equal to 0. So we get x plus 2 equals 0, x minus 2 equals 0, and you guys should be able to solve those by yourself. You get x equals plus or minus 2. Okay? All right, number 8, I would like you to try that one by yourself real quick. See if you can figure it out. Okay? Go ahead and pause the video and see how you do. Okay, well, I got to this point right here, and I can't actually do anything over here. So now it's a quadratic binomial. I can't do difference of two squares, so I'm going to start doing the inverse. So I'm going to subtract it, and we get x squared equals negative 49, kind of what we started with. And now we've got to take the square root. Can't do that. Okay, so x equals no real solution. All right, let's go ahead and flip it over. We got some more examples to do. So I need to get the x by itself. Or I'm sorry, one side equal to 0. So we get x squared minus 2 equals 0. Now, is this the difference of two squares? No, it's not. So I can't do that because that doesn't work. So we have to do inverse operations. X squared equals 2. And now we have to take the square root. So x equals. So what is the square root of 2? Oh my gosh, I don't know what to do there. But this says to round to the second decimal. So we got 1.414. So if I'm rounding to the second decimal, I need to look at the 4. And remember, 5 or more, raise or score. 4 or less, let it rest. So the 4, we're actually going to keep it down. And remember that it's always plus or minus. Now, since we rounded it, we have to use the squiggles. And the squigglies right here, this means approximately. Okay, anytime you round, you should be using those marks. Okay? All right, number 10. We're going to get everything on the same side. And we get x squared plus 4 equals 0. Can we take out a GCF? No, we can't. So it's not the difference of two squares, so I'm going to use inverse operations. And now the next thing to do would be to square root. And can I take the square root of a negative number? Let's see, second quotes. For those of you who think you can. Non-real answer. Okay, this is when you know that x is no real solution. Okay? All right, number 11, I'm going to pause the video, and I want you guys to do the whole thing by yourself. Okay? Good luck. Okay, so we could have taken out a GCF, but this one we're going to solve by inverse. Okay? So I subtracted the 15, I divided by negative 3, and then I'm taking the square root. Now, the square root of 5 is 2.236, and remember, we have to round it to the second decimal. So when we do that, we look at the 6, and the 6 tells us that we have to go up. So that changes to 2.4. Remember, when we take the square root, we can have two answers. We've rounded it, and there we go. So x is approximately plus or minus 2.24. All right. Number 12 through 14. You guys can do those on your own. You can pause the video, see how you do. I'm actually going to skip down to number 15 and 16, but I'm going to write the answers down. So if you want to try them now. Pause the video. Answers will be up in a second. Okay, there you go. Let you look at it for just another second. All right, down here. Now, don't be scared because there are fractions. Anytime you see fractions, you should automatically think inverse operations. All right, so we want to get this by itself first, and we get negative 2/3 x squared equals negative 16. Now, how do we get rid of the fraction? Okay, it's not just doing that little flippy thingy. You have to multiply by the reciprocal. And when you're doing that, you can use your calculator. So negative 16 times negative 3 over 2. Okay? And you're going to get your answer. So x squared equals 24. So now you do the square root, both sides. The square root of 24 is not a pretty number, 4.898. 898. And remember, we got to look at that next number, and it tells me to go up, so that changes to 4.90. Remember, it's plus or minus because we can have two answers. And there we go. So that wasn't too bad. Let's do the next one. Okay, inverse operations. Subtract the 3 first. So we get 1/2 x squared equals 28. Inverse operations, you flip the fraction to cancel it. And we get x squared equals 28 times 2 is 56. And to get rid of the square, we do the square root. So the square root of 56 is 7.483. Okay, we need to round it. So x is approximately plus or minus 7.48. Okay, number 17, you're all on your own. Go ahead and pause the video and see how you do. Okay, when you start by doing this, adding the 56, you get 10. Then to get rid of the negative 2/5, we multiply by negative 5 over 2. That's multiplying by the reciprocal. And we get x squared equals negative 25. So the last step for this, and can you square root a negative? Nope. So x equals no real solution. Okay. Now, I know this lesson can be pretty difficult. All right. So if you have any questions, you need to make sure to come in and talk to Ms. Carranza or myself so we can help you guys out. Because it's only going to get harder from here. All right. Well, thank you so much for watching Algebra 1, Chapter 10.2 Notes. Come find Ms. Carranza or myself if you have any questions. Otherwise, thanks for watching.